Hi, welcome to our math. Today I'm doing a series of videos on exponential and logarithmic models. The population, PFT in thousands, of Horry County, South Carolina from 1971 to 2018 can be modeled by the given exponential function, where t represents the year and t equaling 1 corresponds to 1971. I got this example out of a math textbook. This notation sometimes to me gets a little bit muddled. I tend to like the notation since 1970, so we know the actual reference year versus t equaling 1 corresponding to. But I wanted to put this in here because that notation is, I've seen it in a few textbooks, and so it's good to be flexible in the notation you're used to seeing. Okay, it says use the model to find the population in 1960. I always take the question minus the reference year, so 1960 minus 1970. This is going to be -10. A negative year just means in the past. We are fine with negative years. It just means in the past. It's all good. So P of -10 will be 75.9 e to the 0.0316 times -10. At this point, it's just playing with your calculator, putting that into your calculator and getting 55.3. We come back and see the words in thousands, so 1,000 people. Because we always label our answers. A number without a label is meaningless. All right, use the model to find the population in 2010. Mix, repeat, 2010 minus 1970, in this case is 40. P of 40. So in my calculator, when I did this calculation to get all of these answers before I started, I just backed up, changed the -10 to a 40. I didn't retype in everything because I have a scientific calculator with multiple line display, and I just backed up, changed the number. It was very easy to get this into my calculator. 268.65, again, 1,000 people. I like when the question is asked twice like this, because then I double check to make sure I have 0.0361 instead of 0.361. I can double check that I have everything typed in correctly and I didn't type it in too fast. All right, this last question, according to the model, when did the population reach 380,000? This is a little bit of a tricky question, but I do want to note that you almost always are given input to calculate output and then given output to calculate input. We always like to go both ways in a math class to make sure you understand how to go both ways and do the calculations. First thing, if this is in thousands, we need to take this 380,000 and divide it by 1,000 and get 380,000 as I named it. All right, so then I'm going to take the 75.9 e to the 0.0316 t and set that equal to 380. I wanted to make sure the numbers were of the same notation in thousands. Then before I can do any other calculation, I need to get that isolated. I can't just take the natural log at this point. I need that part of the equation isolated. So I'm going to divide both sides by 75.9 and get e to the 0.316 t is equal to 5.0066. Now, because this is an e, the inverse of e is natural log. So I'm going to take the natural log of both sides. Natural log of e to the, see, I missed a 0. It happens. E to the 0.0316 t equals natural log of 5.0066. This, I wouldn't clear this out of my calculator. I would just hit natural log of answer. These cancel. 0.0316 t is going to equal 1.611. Again, I'm not going to clear this out of my calculator. There's a lot more numbers. I'm going to divide both sides by 0.0316 Again, don't clear it out, just hit divide by, and I'm going to get that t is equal to 50.9, which I will round up to 51. When this is asked when, I'm not going to say in 51 years. I'm going to take that 51. I'm going to add my relative year plus 1970 and get that this is happening in 2021. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.